Okay, I think I should make a start again. So this is part 2 of the BGP techniques tutorial. So as I said before we broke at 3:30, I'm not going to do the Confederation slides, but they are here. So I'll just jump through them, and all I want to say is Route Reflector just changes the full mesh IBGP to a kind of core and then point-to-point type IBGP setup. What a confederation does is take your network and divide it into lots of sub-ASs, and so they have the normal sort of eBGP running between the different sub-ASs, but then at the edge of your network, you put a wrapper around the whole infrastructure and say, well, I'm really AS, whatever. And so internally, it looks as though you've got lots of different networks talking eBGP with each other, but the world still sees you as one network. So that's the difference. I'm not going to go through the details. They're in the slides there if you want to read them. The other thing I found interesting is that ISPs who are on the acquisition trail tend to use confederations because it becomes very easy. If you buy another network that's on another AS, you just wrap your confederation around it. And so that seems to be another, well, a reason to use confederation rather than just route reflectors. And as I say there, the other thing you can do, of course, you can use route reflectors within the confederation sub-AS, and I've seen folks who are doing that as well. So you can still scale the full mesh IBGP within the sub-AS. Anyway, so the next bit I want to look at are 32-bit AS numbers, or I've subtitled it How to Support Customers Using the Extended AS Range. So 32-bit AS numbers, the standards documents are those. 4893 is specification. 5396 is the textual representation, and then there's extended community in 5668. As I said at the start, AS23456 is reserved as the interface between the 16-bit and the 32-bit world. So those of you who are using BGP on older routers or older software, probably wondering about all these 23456s appearing. Guess what? That's your representation of the 32-bit AS numbers that are now being used. So the terminology, 16-bit ASNs generally refer to the range 0 to 65535. 32-bit ASNs are used to refer to 65536 up to the top. And the 32-bit ASN pool is used to refer to the whole range. I don't know how it's ended up like this, but when people talk about the different ASN ranges, be aware that that's what they're generally calling. Well, so when we talk 32-bit ASNs, we mean the ones 65536 and upwards, even though the 0 to 65535 does fit into the whole pool. Now, getting an ASN, go to your registry, you'll get one. Bit of history, so from January 1st, 2007, you could get your 32-bit AS number, and so some early adopters did that. From 1st of January 2009, the registries were giving 32-bit ASNs by default, and 16-bit if you asked for them. So if you wanted a 16-bit AS number, you had to say in the application form. And from 1st of January this year, there was no distinction made. You just got an AS number from the pool. The theory being that all vendors would support it and it would be widely available on all the routers everywhere. What I'm finding is that people are still going to the registry and saying, my router doesn't run 32-bit ASNs yet, can I still get a 16-bit? That will work for maybe a year or 2 or 3 yet, until the original 16-bit pool runs out. So you can't rely on that being there forever. Representation, well, you just write them down like that, traditional format, AS plain format. Some people wanted the dot format, so a bit like communities where you have a colon, so you don't have to write the whole 32 bits. You can do 16:16. Some people wanted 16.16 for ASNs. So rather than writing big numbers, you could write 2.4, which is much shorter. And some people even wanted this AS dot plus. In other words, convert everything to the dot notation. So the old 16-bit range, you'd write a 0 dot something. The only problem is regular expressions break rather spectacularly. Well, they don't break, but they need to be fairly substantially rewritten. I've put some examples there. So matching any 16-bit ASN or AS plain you just do that, which is what most of us know. But if you wanted to do AS dot, well, you could write it like this. There are various other options as well. But it's horrible. You've got to escape the dot in there just so that it will actually match. And if you're using AS dot plus, it looks like that. So it's just the thought of having to rewrite lots and lots of regular expressions for AS path matching was too much for many people. So generally, we found that the operations community was kind of, nope, can't do it. AS dot is nice to look at, but it's not nice to actually implement on a router. Now, 32-bit ASN is backward compatible with 16-bit, so there's no flag day. We don't need to throw away routers, upgrade as in replace the hardware. You don't need to replace the 16-bit ASN you already have. Again, there seems to be some kind of mythology out there that if you're going to use 32-bit AS numbers on your router, you've got to get rid of your 16-bit and get a 32-bit. I don't know where that came from, but it's definitely not the case. You do need to be aware that customers more than likely will be coming with 32-bit AS numbers. AS23456 is not a bogon, and it's not a new ISP that's getting bigger every day. Now, and you also, if you want to support 32-bit AS numbers, in other words, configure it on your router, you'll actually need a router that has software that will let you do that. We'll come to this. If your BGP implementation is okay, 32-bit ASNs will be silently transported across your backbone. I mean, if you look at it, 32-bit ASNs have been used since, what, mid-2006? And nobody really noticed. Well, if you weren't looking, you didn't know about it. That's the way it's really meant to be. Because BGP, luckily, in the specification, it says any unknown attribute should be passed silently across the network. So that's a good thing. It meant that the rollout of 32-bit AS numbers happened without the whole internet having to be upgraded. So how does it all work? Well, if your local router and the remote router supports 32-bit ASN configuration, easy. It just, like it is today. You don't need to do anything. If the local router and remote router does not support 32-bit ASNs, too bad. You can only use 16. So if you get a 32-bit from your registry and your software doesn't support it, you need to do the Dear Registry email and say, can I swap back to a 16-bit, please? Which you can do today, but maybe 2-3 years' time, when you cannot do that, it means you're stuck. If the local router supports 16-bit and the remote router or network has a 32-bit ASN, then we have what's called Compatibility Mode. And it works like this, sort of. So we set up BGP peering. The remote asks the local if 32-bit is supported, so that's the BGP capability negotiation I talked about. The local will say, no, go away, don't know what you're talking about. And so what happens then, the remote says, he's old, he doesn't know about the 32-bit ASNs, I'll try AS23456. The local, of course, has to be configured to peer with 23456, because they can't configure the new big number. So the local configures neighbor AS23456. When the remote comes in saying, hey, I'm in AS23456, it's a matching AS, the BGP session is established. What happens then is the ASN, the network using 32-bit ASNs will include a new BGP attribute called the AS4 path, and that will include the 32-bit AS number information. So that one's silently passed to the network that can't support 32-bit AS numbers. It's silently passed through. All that the network that can only support 16-bit AS numbers sees is the AS23456, which is why you see the 23456 in the path. When it gets back to somebody who can support 32-bit AS numbers, they know the AS4 path attribute, so rather than printing 23456, they grab the AS4 path attribute and put the right numbers back in place. So it's very clever how it actually works. So the 16-bit world sees 23456 standing in for the 32-bit AS number, and the 32-bit world sees it how it's meant to be. So we saw this picture earlier. As I say, the 16-bit world sees that, the 32-bit world sees the real numbers as they are meant to be. And so that's it. So it's actually beautifully simple. The two new attributes, we've got the AS4 path, which is the 4-byte or the 32-bit AS path. So it just contains the 32-bit AS path. because the standard AS path contains the 2, 3, 4, 5, 6s, and then just the swapping is done by the router itself. There's also the AS4 aggregator, which is the 32-bit ASN aggregator information. And as it says there, well-behaved BGP implementations simply pass these along if they don't know what these attributes are about. Of course, there's AS2, 3, 4, 5, 6, which is special. So you'll see more of that appearing. What does it look like? Well, this is just my router that I have in my lab. So v4 prefix originated by AS196.613. So if I do a show IP BGP for that, I get, well, there you see them. Right, so this is heard from, I forget who that is. I think it's some AS2.0.131.072 I get transit from. And then you see the AS196.613. So that's my router supporting AS plane. If I flick it over to the AS dot format, then it prints it out like 2.0 and 3.5 instead. So it's up to you. Generally, you can switch between the two formats depending if you want AS path, regular expression, pane, or not. However, if you have the router that cannot support 32-bit AS numbers, it'll instead print the prefixes like this, 2, 3, 4, 5, 6, like that. So I actually had to go and downgrade the software on this router to actually get the output looking like that. Okay, so that's if you don't support it. You'll see 2, 3, 4, 5, 6. And it's not a bug like that. I know it's unusual to see an AS path looking like this, with the same AS separated by others. But in this particular case, it's not, it's not a problem. It's not a misconfiguration. The other thing is, don't use AS23456 as your own AS number. Some people have tried to do that, and you end up with strange situations. Right. Now, if you don't actually support 32-bit ASNs on your router software, you have a few problems. I mean, it'll all work, but you'll have the inability to distinguish between peer ASs using 32-bit ASNs. They all look the same. They all look as though they're 2, 3, 4, 5, 6. So you're going to have to use something else. I mean, if they use communities, you're all right. But if they don't use communities, they're all 2, 3, 4, 5, 6. How do you distinguish between a prefix's origin AS? Again, they all look the same. You know, which one's real, which one's fake? What if somebody's coming along masquerading as somebody else? It's just 2, 3, 4, 5, 6 to you, so it might be all right. If you're using NetFlow or any of the other type of traffic flow summarization stuff, well, 2, 3, 4, 5, 6, it's all the same. So as I said earlier, you've got this AS that's getting bigger and bigger and bigger. Number one in your traffic flow data. It's not some big new ISP or content provider, it's just the 32-bit ASN internet. So it's actually probably a good idea really to try and move over to software that supports the 32-bit ASNs so that you can implement policies. I mean, I took this list off the Clupon.net website. I mean, okay, this is back in January. I haven't updated it since, but I think it's still pretty much current. So that's most of the list. I think there are a few more on the Clupon site from some of the smaller implementations as well. But it's pretty much all there. I mean, I think all your favorite vendors have got some implementation or other. Whether you want to move to the software or not is another matter. Right, so that was 4-byte AS numbers. Should be pretty simple stuff to implement. Flap damping. So as I say there, stability for the 1990s, because back in the 1990s we thought right flap damping was a really good idea. Network instability for the 21st century, because I think these days most people consider flap damping a really bad idea. So let's see why. Well, the theory first was a route flap is basically a withdraw in BGP followed by an update. In other words, a path is removed, then reappears. That's considered a flap. Flap ripples through the entire internet. It means every router that's got the full BGP table will see your flap. 35,000 autonomous systems, that's a lot of routers. And so flap damping was aiming to try and reduce the scope of the flap propagation. Right, so we try and get the flaps only seen locally. And if people flap, flap, flap all the time, then we try and cut out the unstable networks or unstable paths until they recover. So requirements, you want fast convergence for normal route changes. So if you announce a prefix, it appears. If you withdraw a prefix, it disappears. But if you want to announce withdrawal, then we need to do something about it. So we use history to predict the future. Each flap gets a penalty. When the penalty goes over a suppress limit, then we stop the prefix being announced. The penalty decays exponentially. Once it reaches a reuse limit, then we re-advertise. So all sounds fine in theory. Pretty picture looks like that. So if you flap maybe 2-3 times, depending on implementation, you disappear for an hour, half hour, 3/4 an hour, and so forth. So it's meant to really, if you flap 2-3 times, it's really meant to hit you very, very hard. And I think it's fair to say in the late 90s, it did its job. But then the internet grew big. So the vendor defaults initially were considered too severe. We found that first implementations came in 1995. I think the first Cisco implementation, Cisco implementation means you flap, you flap twice or flap 3 times, you're gone for an hour or something, which is pretty severe, and it was pretty much hitting everything altogether. So in Europe, the RIPE, Routing Working Group, did quite a bit of work on this, came up with some recommendations about good values. So we hit 24s really hard, 23s and 22s not so hard, and everything else you pretty much treat very, very gently. And then it was things like, oh dear, but the root name servers are all announced on /24s too. Well, not all, but a lot of them. So that meant you could knock out the root name servers. Oh, well, okay, exceptions were root name servers. And then it was the whole critical infrastructure argument. If you read the RIPE documents, you'll see, and we're on the mailing list at the time, you'll see some of the arguments about what is and isn't critical infrastructure. But even in spite that, people saying, look, don't overdo RIPE flap damping, people just switched on the vendor defaults because it said in the manual, you must do RIPE flap damping because it's good. They didn't think. And then we had the researchers. So there's some of them pointing out the problems caused when ISPs actually do RIPE flap damping. First problem, if one path flaps, so BGP speakers pick the next best path, announce it to all peers, and increment the flap counter. So you could end up with flaps being created and damped simply by a path changing, which wasn't really quite the idea. If a path changes, it's just one simple change. But it's just as though it's like you say something and it echoes on and on and on. It's quite interesting how you see some of these things. I was helping people doing multi-homing in 2000, 2001, 2002. We'd announce a prefix, and I look on route views maybe 10 minutes later and see it's flapped 15 times. It's like, how is this possible? I only just announced the prefix. And it's done because the BGP speakers change the best paths all the time and causing all these different announcements to different peers. What else? BGP implementations are different transit times. Some of them, if you announce a prefix, they immediately announce it on after doing best path. Well, other implementations hang on to it for 30 seconds, and then they announce it. And so you had this race to the finish line, which did the same thing. Right? You got flap counters being implemented, best paths being changed, and it ended up with a bit of a mess too. So flap damping, by and large, is considered a really bad thing to do these days, simply because it causes more instability than just not doing it at all. Because the internet now is so dense, it's so densely interconnected, the many, many paths between different providers, that it actually will seriously impair the functionality of the network and the internet.
Quick thought, Joey Egley. One of the things that was observed, and part of the reason that we got into flap damping to begin with, was that it was observed that the edges of the network had a tendency to flap at a greater rate than like many sections of the core. And the theory was that as more prefixes appeared, flapping would continue to grow at a linear or higher rate. And the fact of the matter is it's grown at a sublinear rate, which means that even as we add more prefixes, that doesn't mean those prefixes are more unstable. So the great threat that flapping was supposed to alleviate, turns out it hasn't happened. So, thanks.
Yep, exactly. Thanks, Joel. Yep. Can you use the mic, please?
Actually, I have another question with regard to best path. I think a number of vendors are introducing multiple best paths in the very near future, and just wanted to get your thoughts on the impact of that on BGP.
Impact on BGP?
BGP dampening.
Off the top of my head, standing here right now, I would have to go and think about it. I can't see any impact right now, or at least in the BGP flap situation, but I think it's a case of really once we get some implementations and people starting to use it, we'll get a better idea of what's going to happen. But, as Joel was saying, the big solution, and well, this big problem that we were going to have didn't really happen. And really what I'm trying to say here now is that folks who just blindly switch it on are actually causing more damage than just not switching it on at all. But there is actually some write-up in this RIPE 378 document, if anybody wants to look at a bit of the history of it all, so some of the problems and so forth. It's a bit old now, but because this was done a few years ago. But the general recommendation now should be just don't do it. Okay, now I just want to take a quick look through some of the communities. I know it's a bit of a jump. This is kind of BGP scaling as well, even though I've given it a separate title. The subtitle, Making Life Easier for Yourself, I'm actually deadly serious about it. In the multi-homing tutorial I've got lots of examples of using communities and community policy to show you how to greatly simplify things. But we'll just quickly look here. I just want to put some in the BGP techniques tutorial as well. Just, I suppose, get you interested in actually looking at using communities within your network if you aren't actually using them already. Because what this lets you do is group prefixes into different classes. So rather than just having one AS, and you try and do all your edge filtering with all your AS filters and prefix filters, you can actually group them into communities and do all your edge filtering based on communities instead. Each community means a different thing. You can have a different result inside your network or for your peers or your transit providers as well. Now, there are no recommended ISP BGP communities. Again, folks come and ask me, oh, there must be a recommended list to use. There isn't really. The 5 standard communities, they're the ones in RFC 1998, but that was only what Internet MCI were doing. It's not necessarily recommended best practice. They just documented what they did, and other people decided to copy. There have been some efforts to document. There's that long ago expired Internet draft there that documented, I suppose, some of the best practice communities that folks were using. The folks at 1SC document communities. That's kept relatively up to date, which is a pretty good effort. There was a tutorial 10 nanogs ago showing some of the typical service provider communities in use then. But 10 nanogs is what, 3.5 years ago. So things have probably changed from then too. But that's all there's really been, and people just refer to those to try and figure out what to do. So there's no real best practice. People just decide what they're going to actually work with. And once they figure out what they're going to do, they publish it on the website, as some do. Others publish it in the AS object, in the IRR, in the Internet Routing Registry. So I've just grabbed some off the net just to show you. Probably totally invisible from the room, but here's one from Sprint. And if you can make out what it says, well, they've got a list of ASs that are supported here. And you've got things like, well, 65,000 : XXX. XXX is this list of autonomous systems. So if you send them a prefix, and if you're a customer of theirs, with this community set, they will not advertise that prefix to this AS. Right? Or if you send them 6503, 65,003, : XXX, they will do a 3 times prepend of your prefix announcements towards that AS. So in other words, what they've done is they've allowed their customers to do traffic engineering between themselves and their peers, or these listed ASs on the network, which I think are all their peers. Okay, so that's a sort of useful thing. So rather than having the customers phone up and say, who can you change this and who can you change that, they've created these communities to allow customers to do that. So in your BGP announcement to Sprint, you can just tag different prefixes with these communities, and they will do those particular things on the network. So there's more information on their website. So that's one example. I'm not advertising any particular ISP. I'm just showing you examples. Here's NTT. Go to us.ntt.net. So they've got a website listing what some of their policies are. So their default local pref is 120, and they've got various other communities. So if you send these particular communities, again, they will do these particular things. So 2914.40.50 means customer fallback. 2914.470 means it's a peer, and so forth. 2914.411 prepends outbound to customer 1 times, or 2 times, or 3 times, and so on. It's quite a long page of options that are available. So there's some more possibilities. Verizon Business in Europe. So here's another one. This is picked out of the Internet Routing Registry run by the RIPE NCC. So if you look up the OTNAM object, again, well, missing out all the other details, but if you look down to the remarks section, you see again AS702 has got various communities listed there. So again, some more examples. 702.80, set local pref 80 is actually one of the RFC 1998 versions. 702.20 only announced to the ASs and customers. 702.30 keep within Europe. Single prepan, 2 prepan, 3 prepan. So you see the pattern there, the typical things that folks might be using. And there are others. BT Ignite. This is a huge list. And the definitions are based on Tiscali's original ones. I mean, Tiscali's are what, TINet now, but many, many years ago, Tiscali came up with a very, very complex list. And so BT Ignite seems to have adopted them. But here's the typical thing there. So, for example, if you send 5400:1000, they will not announce that prefix to all their peers and transits. Or if you send 5400:2000, they'll do a single prepend. And I've worked with customers of BT Ignite, and I've played around with these communities, and they do actually work as advertised, which is not bad. But you can see the type of things that folks are using communities for. Which, can you imagine trying to phone up a network operations center and explain what you want in English, whereas just with a service provider providing these communities, you can configure all this for yourself to do your own traffic engineering, announcements, non-announcements, and so forth. Level 3, again, I have a very big list, and I don't know how many of these are actually used or if they are used, but still it's an impressively big list if you look up the OTNAM object. So 65001:0 prepend to all peers, 65001 prepend to peers with ASX, and then you've got the local pref setting ones. 3356:999, that one's a great one. And this is not a security workshop, but if you announce a prefix with this community set, they will black hole it. This is great for handling DOS attacks. If somebody does a DOS attack on address space that's yours, rather than it completely filling up your inbound links, what you can do is you can send the prefix is being attacked by BGP to level 3 as an upstream with that community set, and then they will black hole all the traffic coming into that destination within their backbone. So that's really, really useful. I mean, quite a few ISPs are doing this now, more are doing it. I mean, it doesn't mean you just do that and then forget it. You do that and then phone them up and say, I need help trying to get rid of this DOS attack. But I say, this is not a security workshop. You can talk to the security folks about it, but I'm just showing you one example of the community use. Whereas otherwise trying to deal with this in the middle of a DOS attack, trying to phone somebody up and get them to put filters at different parts of the network, it's too much work. Whereas this totally automates it. So another example. Anyway, let's say that's all I'm really going to spend on communities, just to get you an idea of some of the things they might be used for. So we now look at the deploying BGP in an ISP network. So I've got about an hour to go through the rest of this. So this is primarily a lot of good advice. Those of you who know me know that I rant a lot about aggregation. And we'll look at some configuration tips as well. So we'll just look at generally good practice things, skilling the network things, good behavior on the internet type things, at least as far as BGP goes. So let's see. So we've learned all about BGP. Apart from doing multi-homing, but we've learned everything else about BGP. So how do we actually use it? So we're going to look at the role of IGP and IBGP in the network. So BGP versus OSPF and ISIS. There's still folks who say, oh, well, I don't need to use IBGP in the network. ISIS, you've done such a good job, all the vendors, we can carry thousands of prefixes in ISIS and it's all great. Well, that's not the point. Thousands of prefixes in ISIS is not to service some of the tiny little internet cafe. It's there to service the global transit providers, the biggest ISPs, because they've got thousands of routers. So that's why the scaling of it is there. Putting 20,000 customers into OSPF is not good practice. You can do it, but you can do lots of other things that are probably not good ideas either. So OSPF and ISIS, they're used for carrying infrastructure addresses. By and large, your point-to-point links, if you need to carry those, and your loopback interface addresses on your router so that you can run IBGP. That's all that you should find in there. And it's always a nice competition between BGP folks to try and reduce the number of prefixes running around in OSPF or ISIS, because the fewer prefixes, the faster the convergence you can get without using any of the special tricks. Right? So the design goal is to minimize the number of prefixes in your IGP. BGP is used internally and externally, as I was saying at the start. IBGP carries some or all internet prefixes across the backbone and your customer prefixes. That's where you put your customer prefixes. So as you delegate address space to your customers, or they turn up, connect to your network with their own address space, put it in IBGP. Notice this is v4, v6 protocol independent. Whatever I've been saying so far for IPv4 applies to IPv6 too. Nothing changes. Well, all the changes between v4 and v6 are the numbers get big, as far as we're concerned in this room doing BGP. eBGP is used to exchange prefixes with other autonomous systems. And that's where you implement your routing policy. So I said this at the start. There's the model. We saw this picture at the start of the tutorial as well. You've got your IGP, connectivity between routers. IBGP, transferring prefixes across your backbone. eBGP, prefixes between autonomous systems and your policies. So it's a simple division of labor for these three protocols. I still consider IBGP and eBGP different protocols shared by a common name and common configuration because they behave very different ways. So, do not distribute BGP into OSPF or ISIS. Just because there's a redistribute command on your various implementations does not mean it's a good thing to do. Okay? OSPF ISIS designed for fast convergence, small number of prefixes. So dumping 330,000 internet routing prefixes into OSPF is generally not a good idea. The other way around is not a good idea either. Things in your backbone change very, very quickly. So to have ISIS or OSPF knocking BGP every 2-3 seconds just really doesn't make BGP very happy. And don't put your customer prefixes into OSPF or ISIS as well. Even though it might be a small network with only a few customers, you're going to grow bigger. I mean, I don't know, I've met many operators who've said, no, we're only going to have a small network with only 3 routers and that's all it's ever going to be. Everybody has got a growing network. So it's a very good idea to start how you mean to carry on. Because redesigning things 6 months down the path to do route reflectors or confederations or to have customers running in IBGP rather than OSPF, it just wastes time. And so start from the beginning. I mean, if anybody I've knocked on the door of to help with the network design, I've started from the beginning how I intend to scale the network. And they don't appreciate it at the time. It's like, oh, wow, this seems really complicated for just 3 routers. Yeah, but when you have 200 routers, it'll look the same. And yeah, now 5 years later, they appreciate the difference. So always start how you mean to carry on, because then it will scale. If you don't want to do that, then it will not scale. It's an easy choice. Now, putting prefixes into IBGP, so use IBGP to carry customers, don't use OSPF. things that folks do, point a static route to the customer, and then you can, well, redistribute statics into IBGP or whatever else your implementation does. You want to make sure that the prefix always remains an IBGP. I mean, if it's a customer link, a static link to a customer, well, for example, on iOS, if the interface goes down, then the static route disappears. If the static route disappears, the entry disappears from IBGP also, which ends up with route flaps happening inside the network as well. So don't set things up so that static route will disappear if the interface goes down. Make the static route permanent. And then even if the interface goes down, it's still there. So the entry is still an IBGP and you get stable network. Don't switch on BGP flap damping for your IBGP. I mean, or don't even go and ask your vendor for it. Because lots of people do. Oh, well, my network's unstable. I want to have IBGP flap damping. And the question is always, maybe we should have a look at your network design because IBGP shouldn't be flapping. So you don't want IBGP flaps to happen. So nail up a lot of these routes that are used to inject prefixes into IBGP. Okay, aggregation. Aggregation. Now this means announcing the address block you get from the registry to other ASs connected to your network. You'd think this is actually very, very simple, but for some reason it doesn't seem to be simple at all. You can announce sub-prefixes for traffic engineering. Obviously, you're going to see lots and lots of sub-prefixes inside your network as well, because you're going to give pieces of your address block to your customers or your services, server LANs, hosting LANs, whatever you do. You're going to see those in IBGP. The world does not care if you split your network up into /28s. The network cares for the address block that you have. Right? When you're writing a letter to your friend, okay, it may be 6 pages long, for those who still write letters rather than email. You don't take each page, tear it in 2, and then post it in 12 envelopes and expect them to reassemble the whole thing at the other end. Well, I don't know, maybe people do. But it seems to me many ISPs seem to think this is a really good idea. So it just seems, to me, it doesn't make any sense. You know, why would you split things into pieces, send them out there, and expect people to reassemble everything at the other side? You don't do it in anything else. But there's still loads of people thinking in terms of Class Cs. There's still people who come to me, oh yeah, I've got such and such Class Cs from RIPE or Aaron or APNIC. You might have got Class Cs from RIPE, NCC, because they were around in 92, 93. You might have got from APNIC in the early days, but I don't think Aaron has ever handed out Class Cs, because they only have been around since 2000. And Class Cs disappeared in 1994. So you'll see. As I said, as I warned you earlier, it's a bit of a rant of mine, so yes.
No, you make a good point. The question I have is with regard to customers that are multi-homing more and more. Mm-hmm. And part of the challenge is you never know which one of your customers are going to end up wanting to multi-home. Yep. So, you know, you can aggregate your announcements until the customer right in the middle of that block decides that they're going to multi-home, mm-hmm. at which point you can no longer aggregate it. And they're going to be making their own announcements with you as a transit rather than you on their behalf. How do you go about dealing with that?
I still announce the aggregate because the address space is still mine as the service provider. They're just taking one piece out of it. So if they announce a /24 out of a 19 aggregate, they still do it. You don't need to no longer announce the /24.
Right, longest match wins. So like the /19 aggregate still works for every component except for the /24 that's punched out of it.
But anyway, I've got more about this coming. You'll see. So, this, I mean, I don't know. The ISPs who don't and won't aggregate are held in relatively poor regard by the community. I suppose it depends which community and where you look. There's some parts of the world where folks seem to think that, well, if we just take whatever's in IBGP and punt it out to the world, it's perfectly okay. And when I do this presentation or just a summary of it, then people go, what's he talking about? Why is he going on and on about this being such a big issue? But then I also hear what the big transit providers who are carrying 330,000 prefixes have to say about it, and whining at vendors to put even more gigs of RAM into routers and make even faster processors and this type of thing. So there's the win and the lose there. Registries generally publish the minimum allocation size, so it can be anything from 22 to a 20, depending which registry. So you'd think that apart from multi-homing, traffic engineering, you won't see many prefixes longer than /22. Guess what? The more than 168,000 /24s, more than half the table is actually /24s. /24 seems to be the minimum it will reach everywhere. So I guess Sean Duran is not at Sprint doing filtering anymore. Well, that went away, what, 10 years ago, before that kind of filter was present. /24 seems to be the minimum that will get you pretty much anywhere in the network. Although if I look at the BGP table, I see /32s, 31s, 30s, and everything else as well. Anyway, /24 seems to be the popular announcement. Anybody want to take bets on what the popular announcement will be for IPv6? /48 maybe? 64, thank you. Probably right, actually. Anyway, let's look at the aggregation piece. So here we've got an ISP, AS100, he's got a customer, whoops, got a /23, or given the 23 to the customer, and what he does, he takes his iBGP, he's got no outbound filters, and he just sends the whole lot out to the internet. Hey, because it works. I'm only going to announce address space that my customer's using. I'm not going to announce unused address space because it attracts, well, 60 kilobits per second per what, /19? No, it's about 80 kilobits per second per /19. Actually, it depends what range of address space you have. But yes, there's a background noise in the internet which is about 60, 80 kilobits per second per /19. So they don't want this noise coming in. Okay. So what happens in reality? Customer link goes down, /23 is unreachable, it's withdrawn from the iBGP. ISP doesn't aggregate at all, so the withdrawal message goes out to all other 35,000 autonomous systems or whoever's got full BGP table, and they all see the withdrawal. Load on the backbone routers, and that was the intention of flap damping in the early 90s, mid-90s, was to stop this sort of thing happening. Customer link returns, /23 network is now visible, re-advertised to peers, propagates through the internet. Oh, hang about, some people are still doing flap damping. So what, does it actually propagate through the whole internet? Or what happens? No, it doesn't. Some people do flap damping, still suppress the prefix. So what happens is the internet may take 10 or 20 minutes actually to become visible, or even longer. It's a bit like, you walk into your house in the evening, switch on the light, and it kind of flickers and nothing happens for about the next 10 or 15 minutes, and then it comes on. Is that a sort of service? Or you switch on your mobile phone, and you don't get service for another 10 or 15 minutes? Now that's unacceptable in any other world, but why is it acceptable here on the internet? And I find this totally bizarre. Again, it's one of these strange things that some ISPs seem to think this is good. And when I challenge them with this, it's kind of, oh, but it works, doesn't it? The internet it's like any other service. It's, you pay for something, you expect it to be there when you need it. Whereas if ISP was actually announcing an aggregate as well, or even just announcing his aggregate because he's no need to do anything else, it actually works better. Customer link goes down, 23 disappears, withdrawn from AS100 iBGP, and that's it. Because the 19 aggregate's still announced, no propagation delays, nobody else sees the change, and all is fine. Or going back to my analogy, it's a bit like if you switch the light off in your house, the lights around the whole world flicker. You shouldn't have that. Customer link returns, /23 network is visible again, 23 is re-injected into AS100's iBGP, and that's it. So when the ISP or the customer wants his network connection, he switches his router on or his PC on, he can download his email, everything just works. That's how it should be. Well, this is how I was brought up. Maybe it was just, that's how all the folks I was around in Europe were in the early 90s. This is how you do things. There's no other way to do it. Nobody could conceive of any other way of doing it. iBGP was internal, and you just announce your aggregates outbound. But these days it seems to be, yeah, we'll just announce any old junk out to the network. Somebody else's problem as long as it's good for me. Anyway, so why do so many still do it? Is it lack of knowledge? Gosh, I've done enough of these tutorials. Laziness? Who knows? Anyway, so it says Internet Today. This was 31st of August when I was doing the slides. So it was 329,000 prefixes. My view, we're what? We're about a month later. I think I'm up to about 333,000 prefixes now. So adding about 3,000 a month. Wonder what it's going to be next year. Anyway, this is part of my routing analysis. Those of you who are on the NANOC mailing list will see us send a spam every week that sends this report that I'm doing. Jeff Houston sends the CIDR report as well. So you get lots of this analysis stuff that's happening if you want to read it. But one thing I actually do is I take the BGP table as it is and aggregate it. So I do what ISPs have forgotten to do. I actually do the aggregation for them. And the BGP table goes down to 151,000 prefixes if you do that, with no loss of information, no loss of paths, nothing. Quite incredible, really. So we've got 170,000, 180,000 prefixes almost of junk. That's actually a bad sign. There's more junk in the BGP table than there's actually good stuff. So I'm just waiting. I'm waiting for the day that some ISPs say, right, I have enough carrying 330,000 of junk. I'm actually going to filter out and keep only the good stuff. It's got to come soon. It's really got to come. With routers needing almost a gig of RAM now to carry everything. Never mind the poor folks who are doing MPLS and carrier kind of stuff who are carrying multiple versions of this. Either that or they're just going to get lots of gigs of RAM in the routers. So yes, other things here. /24s, 171,000 /24s on the 31st of August. Yeah, almost 35,000 autonomous systems. What else? So it's kind of the new swamp space. I've just put some in comparison. February 99 is when I started doing this. The registry blocks contributed 88% of the routing table. So that was the size. And if you look at some classics here, so 193/8, that's a RIPE NCC, so it's European block. It was fully allocated back in February 99, 2,390 prefixes. People were multi-homing, doing traffic engineering, leaking sub-prefixes, all the rest. Great. What else can I pick on? 203/8, 202/8. I think 202 and 203 are used in Asia. Look at them, 2,276, 3,622. Now watch as I move forward 11 years. 202/8, 11,354. 203/8, 11677. 193/8, 6,820. It's doubled. How can it have doubled? What's changed in the network? I mean, it's fully allocated from the RIPE NCC. Yes, ISPs may have got more interconnections with each other. There probably is more multi-homing going on, but doubled? Or even, well, these are just scary. 11,000. I mean, if the whole internet went to 11,000 per /8, well, I've got some numbers looking at that. I mean, even if we did 5,000 per /8, we would end up with 530,000 prefixes in the BGP table. There are 14 other /8s left. So if we look at all that, 762,000 prefixes. And that's only with 5,000 per /8. What if it went to like 202/8? It would double. 1.6 million prefixes. Hang about, I work for a vendor. Isn't this meant to be a good thing? It means I can sell more memory and bigger routers to the ISPs. But that's not the point. It's just the usual thing. You don't want to make it somebody else's problem. I'm not even going to start on the V4 runout policies in the different registry regions, where the final /8 is going to be chopped up into tiny little pieces. And I'm not even going to talk about address transfer markets, which will probably happen next year as well, which will mean chopping up more of address space. So this BGP table, I'm probably being totally conservative at that sort of size. Who wants to go shopping for memory? Anyway. But it's generally a pretty serious issue, and I kind of hope that ISPs pay more attention to what they're actually letting their customers send them, rather than just accepting any old rubbish. If they're going to do traffic engineering, find out what the traffic engineering prefixes are, and just allow those in the filters. It takes more work, but then it means we don't end up with a massive BGP table. I mean, a big BGP table, think what it does to the convergence time. How long does it take to load into the routers? Is 2, 3, 4 minutes, is that okay to load a full BGP table? Or maybe 10 minutes? If you've got multi-homing, 2 BGP feeds, full BGP table, 1 link falls over, how long do you want to wait for the other link to become useful? Yes, your vendors can do different tricks to make it faster, but what if you don't have a router platform that can do all the tricks? Anyway, these are open questions. I'm not going to go into explanation of them all. Anyway, traffic engineering, I don't think traffic engineering really is all it. There's a lot of, I know there's a lot of wanton laziness out there. Now, the CIDR report, as some of you may remember, Tony Bates started that. When did he start it? 94 or so. He started it as we moved from class full to classless routing. CIDR report was intended to encourage people to start CIDRizing. Because what happened was, before we used classless routing, John Postel was handing out blocks of Class Cs to ISPs rather than handing out Class Bs. So this CIDR report was designed to encourage people with 16 Class Cs, or contiguous Class Cs, or 32 Class Cs, to announce a /20 or /19 instead. And so it was a kind of, I suppose, hall of shame or something like that to persuade people to move over. When I joined Cisco in 1998, and by that time the CIDR report had become a marketing department's dream of, hey, we're number 3 in the CIDR report, we're number 3 ISP in the world. And seriously, people were saying CIDR report was a positive thing. I was like, no, you're not. You're number 3 idiot, because you definitely shouldn't be. You definitely shouldn't be appearing on the list at all. So I looked after it for a while. Jeff Houston, when he left Telstra and joined APNIC, he started doing a lot of work and looking at the routing table. And so the CIDR report is now part of his activities. So I think I've got a few slides about it. It's a really interesting place to go and have a look. There's a RIPE routing working group. We did an aggregation recommendations document, again encouraging ISPs. We're documenting the obvious. Rob Evans and I think it was Mike Hughes and I, when we did it, we just like, well, we're documenting the obvious, but we reckon there's a fair amount of lack of documentation of the obvious. And the hope was it would encourage ISPs to read the document and figure out how really to announce prefixes. Anyway, CIDR report. Web page looks something like this. So yeah, it looks like that. You can do things like, so this one's what? Aggregation Summary. So here it's the number of prefixes being announced. So Jeff's view has about 335,000 prefixes. AS6389 is announcing 3,824. After aggregation, it would be down to 278. So there's the number 1. Savings could be made, 3,546, full of, I don't know, surplus announcements, to put it politely. TWTC number 2, Verizon Online 3, and so on. You can go through the list. Right? Korea Telecom, so this transit network in Korea, again, there's no aggregation happening there whatsoever at all. And you can go through the list. There's some really stunning ones here. I won't point out the stunning ones. I'll end up being sued. But anyway, you can see the list. This is the top, I don't know what it is, top 20 or something. But folks that could do better in aggregation. Some of them have done a lot of work. I should mention China Telecom. They spent about 2 years getting away from number 1 on the list because they didn't really like being there. And so now are they on the list? I don't think they are. There's this one, but that's a different network. So, getting off that list is actually seen important as responsible operation. Anyway, I'll move on. Top 20 added routes per originating ASN. So you can see all these sort of things. So BezekConnect, whoever they are, wherever they are, they've added 143 prefixes and so on, that type of thing. Who's done withdrawn? 219 prefixes disappeared from Belgacom Skynet, either because they switched the network off or they did some aggregation or what. More specifics. So this is looking at advertisements are more specific than original class-based prefix mask or more specific than the registry allocation size. So again, you see the list there who've taken the minimum allocation from the registry for that address block and just chopped it into little pieces. So here, here's a typical thing. At the bottom of the main page of the CIDR report, you can put your AS number in, and it gives you aggregation recommendations. So I did it for AS4755, which is my favorite pick-on one in the Asia-Pacific region, because they're announcing 24s, 23s, 22s, 21s. What they do is, when a customer connects, they announce that customer address block to the internet. They do announce their aggregate as well, but they announce all the pieces. And I say to them, guys, IBGP is not EBGP. IBGP is inside. EBGP is outside. You don't need to announce all this stuff. Oh, well, we're doing traffic engineering. No, this is your IBGP. I get access to your a customer of yours. I can actually see all this. So, and you can do this for all the ASs. Here's another one, another example of what's actually going on. And you pop in any AS and you can see what they do. So, size of routing table, well, router memory, is that a problem? Apparently not. Routers can carry 1 million plus prefixes, 2 million, 3 million. It seems to work in the lab. Gosh, I hope it works in real life. But you can do this in the lab and it seems to be okay. You can put 4 gigs of RAM in there and it'll keep us going for a year or two. What about convergence of the routing system? How long does that actually take? Well, it depends on your CPU. Sure, you can go to your vendors and keep them happy by buying the latest CPUs. But that, it's a bit like, if your car's not going fast enough, do you put a bigger turbocharger into it? So, anyway, BGP updates take longer to deal with. There's also the BGP instability report. And this used to be quite spectacular when Jeff started doing it, but it seems to have calmed down. When he started doing this, it was a RIPE meeting in Istanbul, and it was actually a local host there who was top of the report by a mile. And but the updates don't seem to be quite as bad as we expect, but they're still noticeable. So this is looking at the instability in the last 7 days. So, so in the last 7 days, AS 35567 has sent 71,000 updates. Give you a clue. In 7 days, 10,000 updates is 1 update per minute. So 70,000 updates means they've done 7 updates per minute. How can you do 7 updates per minute? I mean, gosh, there's a lot of flapping going on there. Yeah, even if you count for all the different diverse paths to get to Australia, 7 updates per minute is spectacular. And it's not them, it's also 50,000 from Bahrain, 29,000 from there, 25,000 from here, 23,000 from their regular feature, the top of all these lists, right? So it's quite a significant amount of updates. It's not as spectacular as it used to be. So for whatever reason has caused that. But it's still a large number of updates. Joel?
Yeah, particularly when you see those way out on the edge, it's hard to justify those in the name of traffic engineering. If you only have one upstream, why do I get so many updates from you? That's actually sort of one of the really interesting exercises with some of those. On the other hand, having configured a BGP session that produced one of those at one time, I can certainly imagine how you could do that inadvertently.
Anyway, so, yeah, thanks, Joel. But, my usual offer is to anybody who appears in any of these, I'm happy to come and take a look and see why things are bad and make things better. I'm not here just to whine. Oh, yeah, for sure. In my time. Yeah, definitely. I want to see the internet look better place. I'm not whining here just to whine and look for work. I'm whining here because I want the internet to be a better place for everybody. Because if it's more unstable, then, well, none of us are in business. That's really what it comes down to. So that's really why I'm here looking at some of this. I mean, if you look at the prefixes, Alabama Supercomputer Network likes bouncing lots and lots. 2 of the prefixes. And it's a /17. It's not like it's a /24. It's a /17. 1 per minute. Anyway, I find that hard to imagine. But anyway, that's what's happening. Okay, there's the routing table growth. So it's somewhere up there. If we aggregate it, it'll be somewhere down here. So it's basically we've got all this stuff of pretty much not very useful information. So you can see that off Jeff's work. 35% saving, I reckon, is very easy to achieve. I mean, I know people who have started to filter the junk. They only look for aggregates and so forth. There's a lot of work to actually do it. But they can pull the BGP table down to about 220,000 prefixes. And if customers don't complain, no loss of connectivity. And so they're saving themselves that quite easily. Anyway, that was the end of the rant. Now, receiving prefixes. So the 3 scenarios for receiving prefixes from other ASNs, I mentioned them earlier. Customer talks BGP to you, peer talks BGP, and an upstream or transit talks BGP. They are different. We need to treat them a different way. Right, so if it's for a customer, the first thing to do is check that the address space that they're coming along with is actually theirs to announce. Now, if you've If you've assigned them the address space, that's okay. But if they turn up with an address block and say, oh yeah, this is my address space, please announce it, you're not meant to do, yeah, here, give me your money, I'll announce it. Okay? You're meant to actually check that it really is theirs to announce. Because the bad guys do this. The bad guys look for address space that has not been allocated, and they say, come up to an unsuspecting ISP and say, hey, yeah, announce this. I need to do some bad stuff. Okay? What they might do is look for address space that's used by somebody else, but not actually present on the internet. So it's actually listed as belonging to somebody else, and they just appear because nobody's going to suspect it. So it's worth checking. Look in the WHOIS database. I mean, you can do it, well, there's graphical user interface, there's a command line interface. I've thrown in some examples. These are ancient. I know this one's still relatively accurate. Look it up, see who it actually is registered to. And if it's not, say in this case, if it's not APNIC who's coming along saying, please announce, then you probably should be suspicious. Or something like that. If a customer leaves one ISP and goes to another one and tries to take the previous ISP's address space again, you're not really meant to accept that. Well, you're not meant to accept that because it's some other people's address block. So do check. As for peers, well, they're the folks you're going to exchange prefixes and therefore have a direct interconnect with. They're not going to give you transit. You're not going to give them transit, and you're probably not going to exchange money either. It's a direct business relationship. So what you're going to do there is prefixes you announce, they're going to accept. Prefixes they announce, you're going to accept. And that's it. You're not going to give each other transit or any other thing. So agree what you're going to do. It can either be in a contract, written document, email, telephone call, whatever. Some folks use the Internet Routing Registry still, amazingly enough. And you can use the IRR tool set, and it produces lovely router configurations for you if you want to do it that way. Whereas your upstream provider, well, they're the folks who you pay to give you access to the whole Internet. So receiving prefixes from them, well, is it really necessary? It says special circumstances, see later. That means, well, multi-homing, traffic engineering. You generally will need to receive some semblance of the BGP table if you want to do traffic engineering or multi-homing. If you want to carry the full BGP table, that's fine too. But 330,000 prefixes is quite a lot to carry, and so maybe you only really need a default route. But I don't want to get too much into that. That's a whole other tutorial altogether. Does multi-homing really need to have 2 full copies of the BGP table? Sure, it'll work, but you can get away with a lot less and do just the same thing. So if you get upstream or your transit, get a default route from them. That's probably enough. Or maybe if they don't want to give you a default, you can actually use one prefix from them as a default. So actually think about what you're going to receive. If you want the full table, then again, you need to be careful. Don't accept private address space. So RFC 5735 documents some addresses that have got special uses. Note that it's a list of special use address. Some are used on the internet, others are not. Don't just take RFC 5735 and block everything, otherwise you'll find a lot of things won't work. Right? Private address space, you want to block. Your own address space, you want to block. Don't accept the default route unless you expect to get it. Some people from time to time like randomly announcing the default route, probably because they like randomly announcing several megabits per second of junk. Or it could be a configuration error. But so don't accept the default, because if it comes from a place you're not expecting, it may cause issues with your outbound traffic. And there's still a lot of people not accepting prefixes longer than a /24. Clearly announcing longer than a /24 still seems to work, because you see them out there on the internet. So I reckon not everybody has that filter in place. But a lot of ISP configurations I still see the /24 and longer being blocked. Amongst others, Team Cymru have a list of bogons. They've got the bogon route server for both v4 and v6 prefixes. The v6 prefix bogon server is actually quite fun. It gives you about 22,000 prefixes, which is interesting because the v6 table's only got about 3,000. So one of these days soon, hopefully I'll see the bogon prefixes actually be smaller than the actual v6 table. Anyway, so you can get a BGP feed with these bogons, and you can set up a black hole system using BGP to show you how, so that you can make sure that traffic from unused address space doesn't actually get into your network. Now, receiving prefixes, you do have to be careful. Only accept what you expect to accept. So again, it's just being a responsible internet citizen. Now, the last pieces of this, these are just some configuration tips. Just a few things to finish the slides. So for iBGP and IGP reminders, use a loopback on the router or some other interface that you can't physically remove or shut down or whatever else, and run iBGP between it, because that way you get a stable iBGP setup. I mean, if your network is only one LAN, and you've only got routers on that one LAN, then you probably don't need loopbacks, because you just run the iBGP on the LAN interfaces. But as I said, your networks are going to grow. So if you get a second site or a third site, and you're going to have redundancy, then you're going to need to change it. So do you design it now so that you allow for that growth, or do you want to reconfigure it 6 months down the path? So I tend to, even though it's like two routers on a network, I still tend to set up iBGP between loopbacks. It seems sort of pointless, but it allows for the growth. So if a third router comes along or another site comes along, I don't have to reconfigure things. I just add it into the mix. Make sure that your OSPF or ISIS carries a loopback /32 address. Because if you don't carry it, your iBGP isn't going to work. What about the demarcation zone networks? Now, these are the links to your customers, the links to your upstreams or your peers. What are you going to do with those? Some people use IP unnumbered. What IP unnumbered does is you just say IP unnumbered loopback 0, rather than putting an IP address on the point-to-point link, and this works for v4 or v6, you use, say, another interface's address. Because you don't actually need an address on the interface to send traffic on it. Right, so a lot of people do IP unnumbered, and that way they save a /30 in v4 or a slash something in v6, 64 all the way through to 127. It means you don't have to carry the prefixes in IGP. Use next hop self for iBGP. So you set the next hop to be that of the local router. Then you don't have to carry the external point-to-point link around in your IGP. Some people put the demarcation /30s into iBGP instead. So if you're providing a service that monitors the customer's link, well, you want to be able to monitor it by pinging it or something. If you're using unnumbered, well, there's nothing to ping. Well, you could ping the actual remote router, but it's probably easier to ping the point-to-point link because of the remote. It could be other reasons the remote disappears. Or if you're using next hop self and you're not carrying the external point-to-point link in your IGP, you can't even ping it anyway. So what some people do is they put the external point-to-points into iBGP, and that way the monitoring system can still monitor it. You tag it with a special community, so only the operations center can see the /30, and you don't send it to the whole wide world. But whatever you do, I mean, those are the three different ways of doing it. Whatever you do, don't put the demarcation networks into OSPF and ISIS. And that way you keep your OSPF ISIS nice and small. Right, so next hop self. So I've explained this already. I mean, it helps scale the network. Many ISPs consider this best practice today. Again, looking around most of the well-established networks, they're all doing this. They're setting the next hop to be that of the local router for external prefixes. What else? Limiting the AS path length. Some people do this. Some implementations have, well, I don't know if it's have or more had now. Some implementations had problems with long AS paths. People who were coding only allowed for AS paths up to 255 long. So when somebody sent a path with 256 or 257 ASs in it, it caused memory overrun and corruption in the BGP processes and routers to crash and all this sort of thing. So some providers still limit the AS path length to say 20 or 30 ASs only. Don't know if this is a good idea to do or not. I know some people do it because they say, well, the internet can't well, really is 30 AS hops long. I mean, on average, it's about 5 AS hops. I mean, in my BGP analysis that I do, I think the longest I see generally that makes sense is about 20. You see some people who do it 20 times prepend, probably because they forget that it's longest match routing. But you see some of these 20 times prepends that are the best path, and you think, why are they doing this? I mean, you can't find 20 hops through the internet anywhere at all. So what's a 20 times prepend trying to do? But some people filter. So you've got an AS path limiter on the BGP session to limit it to a maximum of 15 or 20. But here's some historical ones. I mean, 3FFE, the V6 folks here will recognize that as a former 6-bone address. I mean, this one was caused by an error in a BGP implementation for V6, and where I don't know what was going on, but anyway, you can see a massively long AS path here. And this one, here's a prepend, 21 prepend, but it's still the best path. So obviously somebody thinks if they do a really whoppingly big prepend, it'll become really unimportant. I know what they were doing. They were trying to get the covering /19 to take priority over the 24. That's usually the reason I hear. The 24 is always going to win over a 19 unless it's not announced. But it's amazing how many people just don't realize. I think if they do a big prepend, somehow the 19 will become more important. It'll never. 24 will always win over the covering 19, no matter what you do to it. Okay, so yeah, there's one example. Again, I don't know how old it was, but you can look on the internet today and see more examples like this. Here's another one, the BGP TTL hack. Now what this is about is, this is GTSM, to give it its official name, Generalized TTL Security Mechanism. What you do is, normally in your eBGP, your time to live is 1. In other words, you can do eBGP with your direct neighbor. But the problem there is that somebody away from your direct neighbor can set the right TTL and try and set up a BGP session pretending to be your neighbor with your router, because it'll have the right TTL. So to avoid that possibility, if you set the TTL to 255, then the packet getting to you is TTL 254. Nobody can do that. Your attacker out here, even if he tries to set it to 255, well, the packet gets 253 by the time it reaches you. It doesn't match, so you ignore it. So it's a very, very neat trick of trying to avoid anybody doing a BGP attack on you. Of course, the big question is, do people actually use this type of TTL attack on BGP? I don't know. I mean, I guess given that the RFC exists and it was worthwhile work for folks to do, that it was actually could be a potential issue. But it's there. You get some ISPs who actually will support this, others who look at you blankly when you mention GTSM. So, but that's how it works. Again, both neighbors have to agree to use it. It's much easier to perform than doing an MD5, so some people put passwords on BGP sessions. Some people don't like passwords in BGP sessions because, again, a few years ago it chewed up all the router CPU. That issue's been fixed long time ago. But still, some people don't want to use passwords. Whereas the BGP TTL hack is a neat way of making sure that nobody can hijack the BGP session. So it provides security. I mean, I use security in quotes because it probably doesn't provide security, but at least it provides a bit of safety for the BGP session. And there was a February 2003 NANOG, there was a presentation. I think Dave Meyer gave that presentation on how the whole thing actually works. So if you're interested, have a look at that one and see what it's about. Templates. I like using templates for doing a lot of BGP configurations. What you don't want to do is set up a custom configuration for every single router, because it's hard to manage. If you need to update something in the BGP configuration, and you've got 50 routers in your network, you've got to log into each one and go, okay, we've got this here and that there, and what does this thing mean? Oh, this thing is that, but oh, another router, it's something else. You've got different names and different policy filters and all the rest. It becomes a nightmare to try and manage. So rather than doing that, create a template. Set up a template for your iBGP, set up a template for eBGP customers, set up a template for each of your different peers. Then if you need to update things for any of your iBGP sessions, you update the template off the router. And then you can upload it to each one and know that you have consistent configuration across the network. I mean, another thing is, of course, the vendor defaults are not really optimal or even very useful for ISPs. You know, poor old vendors, they've got to try and make defaults useful for everybody. And it's not just service providers, they've got enterprise, they've got defense, they've got, you know, goodness knows, academic and research and colleges and small businesses and home users. Trying to have defaults that work for everybody is a bit much. So rather than sort of getting vendors to do different defaults for different people, which would be wrong anyway, ISPs create their own templates with the defaults that they want, and then you can manage it across the network. I mean, Team Cymru have got various BGP templates. You can look on their reading room, the documents. They've got quite a few BGP templates in there. Again, some of them are getting a bit old, but I need to help the guys get them updated. But it gives you the general idea of what you should be doing and should not be doing as a typical service provider BGP configuration. I mean, it's not just service providers. Anybody who's connecting to a service provider will find them useful as well. But you know, the sort of thing on an iBGP template, you've got iBGP between loopbacks, you've got the next hop self. Make sure you're sending communities an iBGP, otherwise the guarantee of accidents happening. I mean, again, it depends on your different vendors, but if you try and keep it consistent across the different platforms, you're fine. Hardwire BGP to version 4, I agree, this is paranoid. But I see so many people doing it that I put it in here. Or maybe people do it because I put it in here. I don't remember which came first. But still a lot of people setting version 4 BGP. Because you can set version 3 and you get classful BGP if you want. It won't be very useful, but I mean, you can actually do that. Passwords on the iBGP session. I see a lot of people are using passwords on iBGP. So it's a secret that's shared between you and the peer. If the packets don't have the correct MD5 hash, then they're ignored. It generally helps defeat miscreants who are wanting to attack the BGP sessions. I still get the sense that the community is divided about whether this is a good idea or not. As I say, I've done this for years, never had problems, but other folks come and tell me, oh yeah, well, we've had lots of problems because of A, B, and C. I'm kind of, well, whatever. But you find, I'm just saying, you'll find that, especially for eBGP, some of your upstreams demand it. It's mandatory. You will not get an eBGP session with them unless there's a password. Or if you go to an exchange point, you'll find that half the peers at the exchange point want passwords, and others half absolutely will have nothing to do with passwords whatsoever. But anyway, it's a powerful preventative tool. What else? eBGP. Do not do damping. I think I've made that clear. Well, don't do it unless you understand the impact. Definitely don't use the vendor defaults. Unfortunately, the vendors were there first because they had implemented. They had no idea what good defaults would be because the test bed was the internet. We were trying to prevent something. Unfortunately, what we learned on the internet didn't make it back into the code because changing defaults is always a very, very difficult thing to do. What else? Remove private ASs. Private ASs should only be seen inside your own network. They're not meant for public internet view. So make sure you strip them out before you announce them to the public internet. Again, quite a few people forget to do this, and as part of the thing in my routing report, I look for all the private ASs that the people are peering. And ISPs seem to allow them through, and so we see quite a few private ASs out there. Use extensive filters. I mean, I actually use backup. So as well as doing prefix filters, I tend to throw in an ASPath filter just for good measure, just in case. I mean, it's very easy to fat finger a prefix filter. I mean, if you're late at night or no sleep or anything, and you want to make some change and you get it wrong, at least having an ASPath filter or some community filter as a backup will at least ensure that you don't have a major disaster on your hands. It may not be quite as good as the prefix filter was, but at least it can mean the difference between getting the full BGP table into your network coming from a customer, for example. What else? Keep policy language for implementing policy rather than doing basic filtering. I mean, again, the routers have enough configuration variability that you can actually separate the two out. Some people like really, really complicated policy, but you find that some of the policy language is doing basic filtering as well. And certainly if you're learning BGP, try and keep the separation. Once you become a guru, then you can mix it all up and look complicated. And and so complicated that nobody else understands it, which makes sure that your employer has to keep you in a job. Also, use a password on the eBGP sessions if your upstream demands it or your peer demands it. I think they're useful. What else? Maximum prefix tracking. Now, this is another one that's interesting. I mean, if you've got a peer session and you expect to get 10 prefixes from a peer, say across an exchange point, and they break something and they accidentally send you 330,000 prefixes, you probably don't want your traffic going across the exchange to this little peer. So having a maximum prefix track saying, well, if they send us more than 10 prefixes, tear the BGP session down. Or at least send you warnings. I mean, it's all very, very configurable. So it can send you warnings, it can tear the session down, it can bring it back up again in an hour or two time or something. But at least use maximum prefix tracking so that at least your monitoring system can tell you if something's gone wrong. That's a good idea. And I mean, I certainly find some of the European peers at some of these exchange points in Europe, some of the peer requests that come in, I see, yeah, we set maximum prefix tracking for your to X. So please tell us how many prefixes, and then we say, right, we're going to send 10 prefixes. Okay, we'll set your max prefix to 20, because that stops a full BGP feed coming in and breaking the network. Log changes of neighbor state. Watch the logs. Don't just sort of gather logs and send them to the null file. Actually watch the logs. Tie it into your management system. Another one that folks don't think of, make the BGP administrative distance higher than that of any IGP. I mean, certainly in iOS, Cisco iOS, eBGP admin distance is 20. And so it's not, well, it's been a few times I've been involved where somebody has sent a prefix from the backbone, but it's come from another AS in by eBGP, and it's overridden the OSPF. That's not a good situation. Not a good situation at all. Okay, there are many other errors that cause that to happen, but you really don't want your eBGP or iBGP to override OSPF and ISIS. You really don't want that at all. So to, again, guard against it, set the BGP distance higher than OSPF or ISIS. What else? Summary. Yeah. So use configuration templates. Try and standardize the configuration as much as you can. Be aware of standard tricks to avoid compromise the BGP session. As I say, the nano community is pretty good that way for talking BGP things and issues and good practice. Team Cymru's got a lot of useful information as well. You've got the various vendor NSP mailing lists as well. In Cisco, Juniper, whatever, there's all various NSP lists that Jared looks after. Get on those if you want specific vendor configuration information as well. But basically, you want to try and do anything and everything to make your life easier. I mean, that's what engineers want, to have an easy life. You don't want to be working 24/7. Make the network less prone to errors. Make it scale better. I mean, if you can do all that, then you can have an easy life while looking very, very busy. So it's really all about scaling. And if your network's not going to scale, then it's not going to be successful. And that's it, folks. I hope you found it useful. I say that there are two other tutorials in this series. There's a multi-homing tutorial, which, if you go to the FTP site, I showed at the beginning. Actually, I probably should take you back to that page if you want to grab the URL. But if you go to the FTP site here, you can actually find, there's a multi-homing tutorial which follows right on from this. So it starts looking at some of the BGP attributes, introduction, really how to do multi-homing, all the way up to, well, not complicated. I mean, I don't do how major tier ones interconnect with each other because that's really quite sophisticated stuff. But it's the basic steps to doing, small network, multi-homing to 2 or 3 providers, how to go and act at an exchange point and so forth. So that's the multi-homing presentation. If you just look on there, look for something that's got a recent date, if you're interested in that. Sorry? Yeah, that's okay. That's a few years ago, but there's some others that are more recent. I think it was Apricot or Sanog or whatever I did it, but have a look there. There's also a BGP troubleshooting tutorial. Again, the Nano Program Committee asked me to do one, and I was scratching my head about how to do it because troubleshooting BGP is something you learn. So I've taken some of the more useful, popular things or common things I've come across over the last 15 years or so, and put them in a tutorial slide. So if you find those useful, feel free, help yourself. It's publicly available. I say, if they're useful, if you have any questions about any of those, let me know. I'm happy to help. Any questions about this tutorial? As I say, I'm here until Tuesday evening, so again, feel free to ask me. Thank you very much for listening.